So this is just an example in which, like most of you, she canceled out the x's. So she picked 1 and 2, canceled out the x's, and that's what this new one is here. And then she picked 3, because you had to use 3, and 2, multiplied 2 by positive 2, and then got the new 2, which is here. So you don't have to like work up, down, up, down, up, down, but if you'll at least circle or label your new equations, because that question is worth 20 points, but you can earn partial credit as you go. So if you can give me the right new 1, the right new 2, maybe your work happens, your mistake happens later on, I can give you partial credit. If I can't follow what the heck you're doing because you're all over the place, then it's going to be hard for me to give you partial credit, okay? I tried to give you I gave you half a page. So I tried to give you space. So this quiz is a 2-page stapled quiz, which usually freaks people out. It's just 9 questions, but I wanted to give you a lot of space. So it's either crunch it all together and have you do a mess of a scrap sheet of paper, or space it out and waste the extra sheet of paper, which is what I did, okay? But you'll want to just make sure that you give me as much as you can. And then the answer would have been 1, -1, 2. And remember, your answers for these, you'll want to give me in coordinate point format, X, Y, and Z. Questions on this one? Everybody good? Okay, we're going to finish the notes from yesterday, and then I'll go back to going over the answers. Although, remember, Wolfram Alpha will give you all the answers to those questions that you worked through yesterday. But let's finish 7.3. So actually, we won't even finish it today. We're going to get another chunk ahead, enough to get you through your quiz tomorrow, and then we'll pick back up after your quiz. So 7.3, the next part we didn't talk about yet, was partial fraction decomposition. So this is called partial fraction decomposition, okay? What you're doing is you are decomposing a fraction. So you're taking something that is one full fraction, like this thing here on the left, that we would typically be working from right to left on these type of problems. You would have gotten 2 fractions, added them together to simplify it to give you 1. You even would take it a step further. X squared minus 2x minus 8 would probably replace the bottom. So you typically would be working right to left. Now we're going the other order. So we're going from the left side of the equation to the right side. We're taking one full fraction and we are breaking it down into its parts, okay? So we're going to kind of baby step into this process. But what you're going to do first is, if it's not factored already, you're going to factor the denominator of what's there. And then you're going to break it apart for each term that you have, or each of the parentheses that you have. Those would be separate fractions. And then I'm going to teach you how to fill in the values that go there. The good thing is that these all can be checked. But again, like the stuff from before, it's going to require you to have extra time at the end. But if I were to work backwards, if I were to take my answer, which is this is what your answer would look like, and I would combine them into one fraction, I should get my question. So these are all really easy to be checked. You just have to have the extra time. I'm going to actually skip over this. This is the same thing. Kind of breaks it down. The things in the bottoms are called linear factors. That's something you might want to know. Okay, linear meaning they're not squared, that kind of thing. So here's the first 3 steps. We're going to factor the denominator if it's not already factored. Some of them are. We're going to split the fractions for each term that's in the denominator we just factored. And then you're going to give the numerators as constants, A, B, C, and so on and so forth. So if there's 2, it's A and B. If there's 3, it's A, B, and C. If there's 4, it's A, B, C, and D, and so on and so forth. So again, we're going to baby step our way into what these are. The first thing we're going to do is just factor it and split it up. So it says, write the form of the partial fraction decomposition of the rational expression. Do not solve for the constants. So we're leaving A as A, B as B, and so on. So if you look at A, I'm going to look at the denominator and factor it. How would I factor x squared minus 4x? Take out an x. So it would be x minus 4. So those are 2 different expressions being multiplied together, which means I'm going to split these into 2 fractions. One gets the x, and one gets the x minus 4. Now what we would typically do next is figure out what goes in the numerator for each of those. For right now, we're just holding the placeholders, so we're saying this is A and this is B. That's all it wants for now. Next step would be to solve for A and B, which I'll get to in a minute. Easy stuff, right? So B, is that factorable? No, it would stay as x and then x squared plus 3. So if it's x plus 3, you could factor b squared root, but you could factor it. But this is a minus, which does not get factored. So one gets an x and one gets an x squared plus 3. Again, these are my unknowns, A and B. The order does not matter on these. So you could have done the x squared plus 3 first and then the x second. But once we start filling in what those values for A and B are, you'll see that they need a match. Questions so far? All right, now we're going to figure out how to fill in all of those. So the first 3 steps are the same. Factor, split it, give them A, B, C, and D. Then for 4, you're going to take the initial expression, whatever's on the left-hand side, and you're going to set it equal to A times whatever term A is missing from its denominator, plus B times whatever term B is missing from its denominator, and so on and so forth. Then you're going to figure out, you want to cancel out each constant one at a time. So you're going to have to figure out what value of x would cancel out those denominators, or sorry, those constants. Plug them in one at a time. And when you do that, you'll be left with one constant. You'll get that value, and you'll repeat it for each one you have left. All right, so action easier than words here. Okay, so 16x plus 14 equals x minus 3 times x plus 5. So directions say find the partial fraction decomposition of this. So our goal here is to figure out what fractions, when added together, would give me this value. Do I have to factor it? It's already factored, right? So I would say that this equals A over x minus 3 plus b over x plus 5. Now, if I was to combine these into one fraction on the right-hand side, I'd have to give them the least common denominator, right? So what would I have to multiply the fraction that contains a? What would I be multiplying that fraction by? X plus 5. So I would have normally have to do it in the top and in the bottom. And what would I be multiplying b by? X minus 3 and x minus 3. So that's the first step. Figure out what's missing from the bottom, multiply it. Now, what's true about all the denominators straight across? They're all the same, right? Once you get to the point that all the denominators would be the same, you can literally, for the time being, ignore your denominators and just grab your numerators. So I have 6x plus 14 equals a times x plus 5 plus b times x minus 3. Now for as many constants I have to repeat this process, which means there are 2 constants. I'm going to have to do this twice. The first time my goal is to cancel out a. So I'm going to figure out what value of x I can plug in that would cancel out a. So how do I cancel it out? Try to get it to go completely away. What can you multiply by that would get it to go completely away? A 0. So I'm trying to make what's inside this parentheses 0. What value of x is going to make that 0? Negative 5. And then I'm going to repeat this whole process, but this time I want to get the b to cancel out. So what would I make x? Positive 3. So I'm going to go through that process. Everywhere there's an x on the left, I'm going to plug in negative 5. So I get 6 times negative 5 plus 14 equals a times negative 5 plus 5 plus b times negative 5 plus minus 3. And simplify. So negative 30 plus 14 equals a times 0 plus b times negative 8. So now I canceled out a, which was my goal. And I get negative 16 equals b times negative 8. Divide both sides by negative 8, and b is 2. Now I'm going to repeat that whole process by plugging in 3 for x, and this time I'm canceling out b and leaving a. So I'd get 6 times 3 plus 14 equals a, 3 plus 5 plus b, 3 minus 3. I get 18 plus 14 equals A times 8 plus B times 0, which cancels it out. This is 32 equals A times 8, and A equals 4. With me so far? So now I'm just rewriting my fractions that I had from above and replacing the value of A with A, replacing A with the value of A we found and B with the value of B we found. So A is 4 over X minus 3 plus B is 2 over X plus 5. And again, you could work backwards by taking that and combining it into one fraction, and it will give you your question. So I was saying before that the order doesn't matter, but the 4 needs to go with the X minus 3 and the 2 needs to go with the X plus 5. So if I had reversed the order, let's say you had actually factored this, and when you factored it, you did X plus 5 first and X minus 3 second. It's totally fine. Your answer should have been 2 over X plus 5 plus 4 over X minus 3. So the right value still has to go with the matching denominator, but the order on it doesn't matter. Both of those would be right. Questions so far? All right, so again, this one's factored for you already. You just have to split it, okay? Let's pretend it wasn't. So let's say it was x squared minus 7x plus 10. You would just want to make sure that you would know how to factor to begin with, okay? So all the rules of factoring still apply. There could be trinomials. There could be difference of two squares. There could be, I think that's pretty much that's in there. Trinomials with a number on the front, okay? But you'll see a bunch of different mixed-in fractions. So this would get an A over an X minus 2 and a B over the X minus 5. So what's missing from the A is what? X minus 5. And what's missing from the B would be? X minus 2. So now I'm just going to do my numerators. X minus 14 equals A times X minus 5 plus B times X minus 2. What are you plugging in first? X equals 5. So 5 minus 14 equals A. 5 minus 5 plus B. 5 minus 2. And I get negative 9 equals, this cancels out, B times 3, and B is negative 3. And then the second time, I'm plugging in what? 2. So 2 minus 14, A, 2 minus 5 plus B, 2 minus 2. So I get negative 12, equals A times negative 3. B cancels out. A is positive 4. So now when I rewrite those fractions, the A goes over the X minus 2, and the B goes over X minus 5. Now when you see a fraction written, do you typically see a plus a negative? No, right? So when you rewrite this, the negative goes in between so that the leading coefficient in the top of your second one is positive. So if that was like a negative X plus 3, let's say, you would end up taking out, not X plus 3. Well, you'll see that that's possible. But you would take the negative off of both. Natalia?
If the answer for your A or B was a fraction?
We're going to do an example of that next.
Okay.
Good question. Questions on this one? All right. So this is two things in one, kind of. One, it's not factored yet. How would I factor x to the third minus 4x? Take out an x, and I get x times x squared minus 4. Is that factored completely? No. X, and then difference of two squares, right? X plus 2 and x minus 2. So how many terms do I have this time? 3. A over x plus b over x plus 2 plus c over x minus 2. With me so far? So what's missing from my a fraction? X squared minus 4. I would say leave it broken down. You're right. But I would say leave it broken down because it will be easier to eliminate them. So this would be x plus 2 and x minus 2. From the b, I'm missing what? X and x minus 2. And from the c, good, x and x plus 2. So again, I'm going to focus on just my numerators. X squared plus 12x plus 12 equals a times x plus 2, x minus 2, plus b times x minus 2, plus c times x plus 2. So tedious, yes, but hopefully not difficult. Just you have to go through each one, right? So there's 3 of them to do this time. So what could I plug in to eliminate a? Plus or minus 2, right? Does everybody see that? Yes. So I'm just going to pick one, and it doesn't matter which one you pick. I'm going to pick positive 2 because she said that one first. Then I'm going to go through it. I'll go back and do the work, but how would I cancel out b? 2 options again, 0 or 2. I already used the 2, so you can't repeat it because otherwise you'll solve for the same one. You'll solve for c twice, okay? So I'm going to say x is 0. And then I want to go solve for c or cancel out c. And again, I have 2 options, 0 and what? Negative 2. But I don't want to repeat the 0 again because otherwise I cancel out the same variables. So this time I'm going to do negative 2. And then I'm going to go one at a time and cancel them out. So everywhere there is an x gets this 2. So I'd get 2 squared plus 12 times 2 plus 12 equals, now I know it's going to cancel from the a, so you could write it out or you know it's going to cancel. It cancels out my a. It's going to cancel out my b. It's going to leave me with c times 2 plus 2. So I get 4 plus 24 plus 12, 36 plus 4 is 40. And then, oh, this is a whole number too. C is 5. That's the first one. With me so far? You guys are smiling, so you're not enjoying yourselves. Something else is happening other than this. I'm not. Okay, then I'm going to go to 0. So again, everywhere there's an x gets a 0. 0 squared plus 12 times 0 plus 12. If I plug a 0 in, which one will not cancel? The a. So I would keep the a, 0 plus 2, and 0 minus 2. And I get 12 equals a times negative 4, and a is negative 3. Still with me? And then I go to negative 2. So negative 2 squared plus 12 times negative 2 plus 12 equals, if I plug in a negative 2, which one's not going to cancel? B. So B times negative 2 minus 2. Oh, that's a B. Oops. All right, so I've got an A, which is -3, a B, which is -1, and a C, which is 5. Everybody still with me? Yes? Again, tedious, not impossible, right? So now I want to just rewrite my numerator with the variable or the constants now replaced with their values. So A we said was -3, so -3 over x. B is -1, so this is -1 over x plus 2. C is 5, so +5 over x minus 2. And then again, this, when combined, should give you your question. Yep.
What if you end up with a fraction?
I'll show you. Yeah. So the question came up, what if it's a fraction? And it's a valid question because you're going to see it. So let's just say A ended up being 2/3 and B ended up being 5/3, something like that, right? And my denominator was x plus 3 and x minus 2, something like that, right? You cannot leave it as a complex fraction. So you don't want a fraction within a fraction. Just take your denominators out and pull them in the front, right? That's the same thing as saying 5/3 or 2/3 divided by x plus 3, which would be 2/3 times 1 over x plus 3. The 3 would go to the bottom. The x plus 3 would go to the numerator. So you're basically just taking that 3 and pulling it out front. So you rewrite it as 2 over 3 times x plus 3 plus 5 over 3 times x minus 2. Now, I'm okay with this, especially for tomorrow's quiz. But if this was multiple choice, or as we get further down the road, what will happen is that fraction will get pulled out front. So they are both being multiplied by a 1/3. With 3 is in the bottom of both of those fractions, which means it can be rewritten as 1/3 times 2 plus x plus 3 plus 5 times x minus 2. So again, for tomorrow's quiz, leaving it this way is totally fine. Do not leave it with a fraction in the numerator. You got to make sure you pull the denominator down at the bottom. But if it was multiple choice, you're going to see it like this. Question on anything partial fraction related. So I'm not going to do repeated factors with you today. It's not on your quiz. We'll do it before your test, which is what the rest of this notes are. Okay. Just a quick quiz review, kind of expectations for the quiz. So I posted that quiz review yesterday. I think there's 4 problems on the homework for partial fractions, like I separated it off. So you're going to want to practice the partial fractions. And then 7-1, which is, so 7-1 is your substitution and graphing.
Do you need a calculator for tomorrow?
You can use a scientific calculator only. You don't need it, but you're going to want it. So there will be no borrowing. I'm not lending mine out, even if there are tears, because I am cold-hearted and I don't care. No, really, just because you can do it without. It just, like I said, it won't be fun. It's going to be way easier to do it with. So that's 7-1, and then 7.2 was elimination. And 7.3 is your 3 variables and your partial fractions. There were word problems in both 7.1 and 7.2. So like we're talking break even, equilibrium point. We did ones with perimeter. We did ones with interest problems. We did ones where like you had ticket sales or calories in a burger, all that kind of stuff where you had to set up a system and then solve it. Expect to see those. I said, somebody asked how many word problems there are. I said, I don't really consider equilibrium and break even. Yes, there are words in those problems, but you are given both equations and you just have to set them equal to each other. So I don't count those. So if without those, there's 2. But obviously with those, there's more. And there's 3 variable like the one we did in the warm-up today. There's 1 triangle one where you just have to do the back substitution, plug it back in. There's 1 partial fractions. There's 9 total questions. Questions as far as expectations go from me? Yep.
For graphing, are we just going to be graphing lines?
Yeah, I just did lines.
Yeah.
Yep.
Those are kind of hard.
I did it. I actually had a parabola on there and I took it off. I was worried about time. So it's just lines. And it's only 1. The other ones you can choose substitution or elimination, your choice. That might come back for test. But at least for the quiz, it's lines. Okay. Any other questions? Again, scientific calculator. Don't forget it. You're going to want it.